A 20 kilogram sign hangs from two cables, each with a 30-degree angle from the horizontal. Find the tension in each cable. This drawing shows the vectors of force acting on the sign. Split up tension 1 and tension 2 into horizontal and vertical components. However, we don't need the horizontal component in this problem. Because the angles are equal, T1 is equal to T2. However, 20 kilograms is not the weight of the sign. 20 kilograms is the mass, but we need to get the weight, so we multiply 20 by 9.8, which is the force of gravity on Earth. This equals 196 newtons. This number is the sum of the vertical components of T1 and T2. Since T1 and T2 are equal, we are going to multiply 2 by T sine 30 to equal 196. Solve for T. Divide both sides of the equation by 2. We then get T sine 30 equals 98. Now, divide both sides by sine 30. The sine 30s on the left-hand side will cancel out. After calculating 98 over sine 30, T equals 196 newtons. A 10 kilogram sign is supported by cables at a 30-degree angle and 140-degree angle. Find the tension force in each cable. Notice in our drawing that one angle is larger than the other. We will have to use a different method to solve for each tension force because T1 is not equal to T2 in this case. Next, we will break up our vectors into their vertical and horizontal components of sines and cosines according to their individual angles. We also have to get the weight for 10 kilograms, which is the mass. So we will multiply 10 by 9.8, or the force of gravity, to equal 98 newtons. Now we put together an equation of T2 sine 140 plus T1 sine 30 to equal 98. Because we have two variables, we will have to put together a separate equation for either T1 or T2. We have decided to solve for T1. Our second equation will be the horizontal components of T2 cosine 140 plus T1 cosine 30 to equal 0. Next, we will subtract T2 cosine 140 on both sides. Divide both sides by cosine 30. The cosine 30s on the left-hand side will cancel out. So T1 equals negative T2 cosine 140 over cosine 30. We will now plug this back in to our original equation. Our modified equation will be negative T2 cosine 140 divided by cosine 30 multiplied by sine 30 plus T2 sine 140, all equal to 98. Next, we will pull the variable T2 out in front of the equation and multiply sine 30 by negative cosine 140 over cosine 30. After doing all of the math, we will get T1 equals 79.9 newtons and T2 equals 90.3 newtons. Congratulations! You now have the know-how to solve your own tension problems.